In Java 7, Java introduced some pretty great and useful classes and packages to deal with file management. So these are all in the java.nio.file package, and the classes in this package allow us to manage files. They allow us to do things like delete files, rename them, move them, copy them, see when they are modified, all sorts of things like that. So there is a lot in this NIO package. I am not going to go over everything. This is meant just to be an introduction to some of the things you can do with that package, but this is not meant to be an exhaustive lesson because there is a lot there. So I do encourage those of you who are interested in learning more about working with files to go deeper into the NIO package than what I'm going to cover here and to learn more of what's there. But some of the classes that are introduced that we'll talk about here are paths and files. Now notice the S there, paths and files. That's important because there is also a file class and a path class, but this is the plural one with the S. So a path name is a path to a file. When you send in a file name to that constructor, like to the file constructor or to the file reader, file writer, it assumes that that file's in the same directory where your program is. Okay. But if it's not, you have to give it more information. You have to give it a path to the file. You have to give that constructor a path to the file. So that path name gives the directory or the folder where that file exists, and it also might give the name of the file. That would be the path name. The full path name gives a complete path from the root directory all the way to the file. A relative path name gives the path from where you started and then deeper into folders where the file is located. Okay, so you can have a full path, you can have a relative path. Path names will differ depending on what operating system you're using. So this might be, for example, what a Unix path might look like, and this might be what a Windows path might look like. An important note about Windows paths, if you are putting them into your Java classes, you have to use the double slash here in place of the single, because the single is what is used to denote an escape sequence. So in order to actually use that, you have to use the double. So that Windows path would actually look like that. User-friendly feature of Java, it will actually accept your path name written in either format. So it will parse that format. Even if you're on a Windows machine, you can give it a path in the Unix format and it will still be able to accept that and figure out what the path is. So that's pretty great. So the path class. The path class represents a path, and you can use a path object to store a path to a file. You can use the paths, plural, class to create that path object. So for example, if you want to create a path object called myPath, you can specify paths with an S dot get. So this is a static method in the paths class, and you can send in the location, and that will create a path object that's a path directly to that file. That location can be a single string, which might be the name of a file, or it might be a full path, or it might be a relative path, or it can also be multiple strings that each list a directory in that path. So you could send in home, files, and Java if your path was the home folder slash file folder slash Java. So you can send it in this way, which is really helpful if you're kind of reading directory names from somewhere else, or you can send it in as a single string. Once you have that path object, there's lots of useful things you can do. So you can get the file name. If it has a file name, you can get the name, which at a certain position, which would return the path element corresponding to that number. So if it's, C users, JMasters files, and I sent in, the number, let's say the number 1, I think that would give me users, right? So you can get the name of different components of the path. You can find out how many names are in that path. So you could use these two pieces together to create a little loop, looping through each one of the names in the path. You can get the parent of your path, you can get the root of your path, and there's other things too. So you can really do things with that path object once it's created. Similarly, there's also a files class, so files with an S, and this also provides static methods for working with files and directories. And these methods also work on path objects, so you can create that path object and you can use it with these files methods. Some of these static methods are exist, not exist, readable, writable, is it a directory, copy, move, delete. So all sorts of things you can do to manage files, you can do with these static methods in the files class. And again, you can pass in path objects to those methods. The files class also can read and write from text files. So there are some pretty nifty little shortcuts to reading in everything from a text file or writing everything out to a text file. So we looked at in a previous program having a scanner object and doing a loop and reading everything in to a list, for example. Or you can use this handy little static method read all lines. So if you have the files static method read all lines, if you have a path object, you pass that in, and what it does is it reads all the lines in that file and puts them in a list. One line per string, puts all those strings in a list. So that would take, a lot of declaration of scanner and looping and adding and all of this, or we can just use the single line from the files class. So that's pretty great. Similarly, if we have a list of strings and we have another path object, we can say files.write, and that will write that list of strings into that path object. So these read and write are pretty useful. Again, you can think about how much code that would take to do it manually. Part of what we did something similar to that earlier, and then you can look at how easy this is to just do the single method static method call. So there really was some nice stuff introduced with this NIO package. There are also some enums in the package, and you can use some of those enum values to do things like append. So here with our files.write, if we didn't want to overwrite the file, but we just wanted to add on to the end of it, we can still invoke that write with our path and the lines list, and then we can use this enum standard open option .append to specify that we want those lines put at the end of the file. We don't want it overwritten. You can also, if you are copying, for example, you can replace an existing file. So if we copy from an old path to a new path, we can use the standard copy option, which is again another enum, to replace the existing file. And there's some other options in that enum as well. So there's a couple enums in the files class that are useful to know. If you're looking at one of the files methods, it might show you a parameter of one of those enum types, and they just use those to kind of give you different options of what you can do with a file or a path. So let's just actually see this in practice. I think that's kind of the best way to go about working with this NIO package.